Okay, hello, Dawson. So let's start. I think not much of people attending there. So okay, so we did number 8 and number 9 is about the finding critical passage and its ranks. And in this case, there are three passages, puzzle passage. One is here, one is there, and the another one is here. And if you just add all the minutes, then what you can get is this pass has 3 plus 4 plus 5 plus 1, which is, what is that? 13 minutes. And this one is 3 plus 6 plus 9, which is 18 minutes. And the next one is 7 plus 4, 3 plus 7 plus 4 plus 9. So it is 10 plus 13, so it is 23 minutes, right? So that's why we take the last pass, T1, T3, T4, T7 as a critical pass, and the optimal one, and the completion time for optimal scheduling is 23 minutes, right? Okay. Do you have any question, Dawson? Great, thank you. Okay, so, and next one is about the Hamiltonian circuit. So how many Hamiltonian circuits in the complete graph with 9 vertices? And if you see about the complete graph, for example, then we know that from formula, right? So here, Hamiltonian circuits in the complete graph with 9 vertices is just 9 factorial. Then you can calculate the other ones by your calculator. And I just want to record that if I just ask you, right, how many Hamiltonian circuits, then it means that it implicitly means that, yeah, separate circuits are counted. No, separate, no, what I mean, mirror images are also counted. The images are counted as separate circuit. But otherwise, if I want to, yeah, want you to calculate the Hamiltonian circuit where mirror images are not counted as a separate one, then I will definitely mention that those in the problem. But in this exam, in my memory is correct, then the only problem is finding Hamiltonian circuit of a complete graph with some vertices, right? So yeah, so I think that you can use your calculator to calculate this in your exam. So there are no problem to calculate it. Okay, great. And also be careful about the case that how many Hamiltonian circuits starting at specific point, right? If you see this kind of statement starting at specific point, in that case you need to divide it by 9, or it is n minus 1 factorial, right? So in that case it is 8 factorial. So without this statement it is 9 factorial, but with this statement starting at some specific point you have 8 factorial. So be careful about these two distinguished cases. Okay, so and okay, I think that you're familiar with this. So let's deal with the number 11. How many edges are there in the complete graph with 9 vertices? So to deal with this, then for example, if you have some kind of, for example, if you have some complete graph with poor vertices, you can see that actually each vertex has balance 3, right? So this happens when complete graph with poor vertices, right? Then complete graph with n vertices, each balance of the point is n minus 1, because complete graph means that every pair of edges, pair of vertices have an edge, right? So and for each point you can have a pair for all other points, so they have balance n minus 1, and we know that it has n vertices. So from this, the sum of all balances are n times n minus 1, and we know that d is equal to 2e, where e is number of edges in the graph. So e is n times n minus 1 over 2. And for Catherine, we just deal with this number 11. How many edges are there in the complete graph with 9 vertices? And to find this, you can think that complete graph with n vertex case in general, and each of the vertex has the balance n minus 1, because every pair of vertex has an edge, right? So the sum of the balances in this case is n times, because we have n vertices, and n minus 1, because each one has n minus 1, right? So d is equal to n times n minus 1, and we know that d is equal to 2e, where e is just number of edges in the graph, so e is just divide this one into 2, right? So apply this formula on our question. Then you have 9 vertices, and each vertex has the balance 8. So it is 9 times 8 over 2, which is 36. And please be careful about the calculation, because I had wrong at first time. And thank you, Dawson, for correcting me. But anyway, so do you have any question on 11 or 10? Is everything good? Then we can deal with the number 12. So use Kruskal algorithm to find minimum spanning tree, right? So in the exam, there are similar graphs with it that comes up, and Kruskal algorithm is just nothing but the same as sorted edge algorithm, right? But in the sorted edge algorithm, we need to care about 2 cases where one vertex has balance 3, or it forms a cycle without containing all the points in the graph, right? But in case of Kruskal algorithm, it is finding a minimum spanning tree. So in that case, you don't need to worry about the case when a vertex has balance exceeds 3, right? So in this case, just be careful about you do not have any cycle, because our objective is now to find the minimum spanning tree, not to find the Hamiltonian circuit, right? So sorted edge algorithm is for Hamiltonian circuit, but Kruskal algorithm is for finding minimum spanning tree. So that's the difference. But the methods are very similar. So first of all, find the minimal weight edge first, and definitely 1 is the minimum among all other numbers. So we need to choose DA because it has 1. Then again, the next one is 2, and you can choose AB because it doesn't form any circuit. And again, 3 is the next number, so you can choose EB, and still it doesn't have any circuit. And then 4 is the next one, so you can choose EC, right? Still it doesn't have any circuit, but the next number is 5, so if you want to choose the DC, but if you add DC on your graph, then it gives you a circuit, right? So you cannot choose a DE at DC at this point, right? So you do not choose DC at this point, so just ignore it. Then next number, next lowest number is 6, which is F3, and then you choose F3 because it doesn't form a circuit, right? And then the last one is 7, which is FD, but if you add FD, then you can have a circuit, but 3 doesn't contain the circuit, so you cannot add 7, right, at this point. So these are all available ones, so the result is this one. So this is the minimal spanning tree. So yeah, I think that in the exam, there are one problem about the Kruskal algorithm to figure out the weight of the minimal spanning tree. So weight of the tree is just sum of all weights in the edges. So weight of minimal spanning tree is just sum of weights of all edges. So in this case, it is 1 plus 2 plus 3 plus 4 plus 6, which is 16. All right. Okay. Do you have any question on number 12? Okay, great. So let's deal with the nearest neighbor algorithm. So first of all, you can figure out that this table seems a little bit weird because I didn't fill out some of the numbers, right? But when you see such a table showing the distance between some two series or two prices, then it is always symmetric, which means that the distance from A to B is the same as distance from B to A, right? So in this case, you can actually add using the number 5 to add 5 in this point, and in this case, it's 2, 3, 4, 5, 6. So as you can see, along this diagonal line, this is kind of, reflection, right? So this 5 corresponds to this 5, this 2 corresponds to 3 corresponds 3, 4 to 4, 5 to 5, 6 to 6. So that's why we call it as a symmetric table, right? Or symmetric matrix if you know the some notions in the mathematics, but just forget about matrix. Then just focusing that it is symmetric. And we just delete this one as 0 because distance between A to A is definitely 0, right? You are already here, so you don't need to move up. So these are why we just delete it. So from this, use the nearest neighbor algorithm and sorted algorithm to find the Hamiltonian circuits starting at B, right? So in this case, starting at B, so definitely we just put B first. Then from this table, the nearest one from B is C, right? Because if you want to go to A or D, then you need to take 5 minutes. But if you want to go to C, then it only takes the 4 minutes, right? So just take C as a next point. Then after you go to C, then you already visited B, so you can just delete the case B. Then only left possibility is A and D, but definitely A is much more nearer than D, so you need to choose A next. And still, when you go to A, then you already visited B and C, so just delete B and C part. Then only possible choice is just D. And then you need to go back to B because you already visited all the cities in the table, right? Okay, hi, Abud. We are just talking about the number 13. So yeah, so in this case, what I talked last is that this table is kind of symmetric. So the distance from A to B is the same as distance from B to A, right? Is it just packed? So you can always make your table as a symmetric table so that this pipe corresponds to this pipe, and 2 to 2, 4 to 4, 5 to 5, 6 to 6, and 3 to 3, right? So along this diagonal line, you can see that this table is symmetric, and by using nearest neighbor algorithm, you can get this path. And if you use the sorted edge algorithm, then first of all, you need to put some, because the most smallest number in the table. So I just delete some of the line because it seems not nice to see. So it should be 2, it should be 4. Okay. So here 2 is the most smallest number. So you need to choose the line CA, right? And next smallest number is 3. So you can choose DA as your circuit. And still, you know that CAD doesn't make any circuit, right? Or it doesn't make any vertex has better than 3, so you can choose it. And next smallest one is CB. So again, you can choose CB. Or if you're not familiar with this kind of thing, then you can just draw the graph in this case because it is simple. So if you just draw A, B, C, D, then what we did is taking CA first and taking DA next and taking CB next, right? Then from the graph or from the things, you can see that the only possible choice right now after choosing 3 edges is taking BD, right? Because that makes your cycle containing all the vertices at once, right? So and BD takes 5. So your roots, if we start from B, then it goes to C first and goes to A, goes to D, and goes to B again, right? So that's why you get the same Hamiltonian circuit as we did in the nearest neighborhood method, right? So in the actual exam, yeah, this kind of thing, you need to write down not only the answer, but also the region how you choose such things, yeah, right? Then you can get the full credit. Okay, do you have any question on this? Okay, great. And next one is about the meaning of dead-headed edge in the circuit. So yeah, in this point, dead-headed edge in a circuit is just some edge which is used twice in the circuit, right? So for example, yeah, if you have a circuit like ABA, then you can see that it is just going to B and going to back to A again. So it uses AB twice, right? And if you have ABCBA, then AB, BC, CB, BA, then both AB and BC are dead-headed edges, right? So in this case, again, AB, B, and BC are dead-headed edges. And so in the actual exam, I will ask about how can you make some graph with such that every circuit is dead-headed edges, right? So for example, this kind of line graph, or yeah, or this kind of star graph. So for example, yeah. Also, this kind of graph, you cannot have a circuit without dead-headed edge, right? Because always, if you want to go back to where you stand, then you need to use the path on edge you already passed, right? So this kind of thing, then you can see always dead-headed edge happen. So especially for any tree, yeah, in a tree. Oh yes, so in this case, every edges are called bridges. So bridge means that some edge, just if you just delete that edge, then the remaining parts are separated. So if you just, for example, if you delete this edge, then this point and the other point, other graph are separated, right? So that's why we call it an edge bridge. So in this case, these three edges are called bridge, right? So for example, usually in this kind of situation, in this case, only this edge with blue one is bridge, because if you just delete it, then it separates this point and the triangle. But for any other edges, oh, sorry. For any other edges in here, for example, if you just delete this edge, then still this point is connected to other points, right? Using the other passes, right? So in that case, this edge is not a bridge, or this edge is not a bridge, right? So what I want to say in this example, or this question, is that tree, you know what the tree is, right? Tree is some graph with a circuit, right? Tree circuit in tree is always have a dead-headed edge, right? So then maybe this information may be useful for the exam. Okay. Do you have any question on this example or anything else? Go ahead, Ibiud. What is your question? Tree method start with K. That's Kruskal algorithm. That's what we did in the number 12. And Kruskal algorithm is very similar to sorted edge algorithm. So it is just, the objective of Kruskal algorithm is find the minimal spanning tree. Yes, I did it, but I just repeated very quickly. So you can see that actually, yeah, it is just start with the smallest number weight edge and choose it and choose it and choose it and choose it. But when you choose the number 5, then it gives you a circuit, right? So in that case, disregard it. Then choose the next one, 6, and for numbers weight with 7, it also still make a kind of circuit, right? So disregard it. Then you are done, right? So Kruskal algorithm is just finding tree, yeah, by selecting the smallest weighted edges, right? So it is very similar to sorted edge algorithm. That's why I write down in here. But in case of sorted edge algorithm, you need to care about two things. First one is having your choice doesn't make vertex has balance more than 3, right? But in case of Kruskal algorithm, you don't need to care about this. All you need to care in Kruskal algorithm is do not make a cycle. But in case of sorted edge algorithm, you also need to care about your vertex doesn't have with balance 3, right? So for example, if we want to find the sorted edge algorithm to figure out the Hamiltonian path of this graph, then I'll use the blue one. Then you need to choose this one, this one, this one, this one. But you cannot choose this 5 because it makes circuit without visiting F, right? So this one is not chosen in the sorted edge algorithm. But also you cannot choose number 6, which is EF, because it makes your E has balance 3, right? So here, sorted edge, the objective of sorted edge algorithm is to find the Hamiltonian circuit. So it needs to create have all the edges, right? So the only possible one is 7, TF. Then you can see that actually, since this is not a complete graph, so we cannot get any circuit in here. But at least we have a Hamiltonian path with smallest to weight, right? So that's the difference between sorted edge algorithm and minimal spanning tree Kruskal algorithm. Does it make sense? Okay, great. So yeah, so be careful about both of it because a lot of students has some mistake on distinguish them. So for the filling blank program on the exam, will it be like filling a mass sensor or like filling a term like Euler path? So there are 2 types of filling the blanks. So one filling the blank is just type the math question like so, like number, or type YN or TF, true or false, like this. So these are called fill-in the essay questions. You can see in the eCampus as a fill-in the essay question, fill-in the blank question. But there are second type of question, which is called essay. So in that case of essay, you need to write down your answer using usual sentence, like, like number 2. So you need to write down every sentence in the question if you see that the question is of type essay, right? So there are 2 types of question, and these are evenly distributed usually. Okay. Does it make sense? Great, thank you. Okay, so let's deal with the next one. So we did it a lot, but still just repeat one more time. So using the decreasing time priority list, schedule this task on 2 processors with their list processing algorithm, right? So first of all, you need to use the decreasing time priority. So here, the most longest one is T6. So T6 should be in the first one in your priority list. And next one is 7. So which is T5. So next one is T5. And next longest one is T4. So you need to put T4 in here. And next one has T1 and T3, right? But if you have such a tie cases, then you need to put the lowest number first. So lowest index number first. So in this case, T1 has lowest number compared with T3. So you need to put T1 first and T3 next. Then the remaining one is T2. So T2 gives you 1. So you need to write down priority list. Then, yeah, then you can make a schedule of them. So first of all, T6 and T5 will be done by P1 and P2. So at the time 0, P1, P2 are available. So you can put T6 on P1, T5 on P2, right? Okay. Then after 7 minutes, then P2 was available because T5 was done. So P2 is available. And after that, now the available job is T4, right? So just put T4 here. So put T4 here. And at the 8 minute, now P1 is available. So just put next priority one, T1 here. And then T4 takes 6 minutes and T1 takes 5 minutes. So after 13 minutes, then both processors are available. So the remaining one is T3 and T2. So just assign T3 into P1 because T3 is more prioritized than T2, and just assign T2 into P2 to deal with all the tasks. Then after 5 minutes, then your jobs are done. So you take 18 minutes, right? And in this case, again, I just wanna, oh, sorry, size. I just wanna record how to get the optimal schedule. So optimal schedule time is maximum of both the longest task, and the number of total time over number of procedures, right? Processes, right? So in this case, the longest one is 8. So each one of the 8, or the total time is 8 plus 7 is 15, 6 plus 5 is 11, 5 plus 1 is 6. So it is 17 plus 15. So it is 32 minutes, 32 over 2, which is 16 minutes, right? So the optimal schedule time is actually 16 minutes because one of the maximum ones. So this one is not an optimal schedule, right? Usually if your tasks are just so many, then your optimal schedule should be determined in the second case, right? But if your task is just so small, or some task has the biggest numbers, so for example, maybe T6 takes 18 minutes, and all other tasks are not or it's just the same, then in that case, T6, yeah, is the 80 is the optimal case. So usually, so it is not, mathematical law, but in case every schedule time and completion time for each task are similar to each other, then the second case is the optimal schedule, but they are very broadly, or they have some variance very big, then the first one is the optimal one, right? So yeah, so it depends on the numbers of the completion times, right? Okay. Do you have any other questions? Okay, Abid, go ahead, your question. Yes, I did in the last time, but I can review for you. You mean number 6, right? So here, how many edges are there? You can use the formula D is equal to 2E. Yeah, then you can see that D is the sum of balances. So sum of balances is 6 plus 6 plus 2, which is 14. And E is number of edges. So you can divide 14 by 2 to get the number of edges. So in that case, it is 7. So yeah, okay. So you can see the notes. Okay. Okay, I will just get back to the last problem. Okay, so in the exam, as I said earlier, so there will be some problem like draw a graph with specific properties. So in this problem is just draw a graph with at least 2 vertices for which all the vertices have different balances, right? So one of the answer is using 3 vertices and adding 3 edges. So here, say this one is A, B, C. Then A has only 1 edge, AB, and B has 3 edges, AB, BC, and BC again. Or you can see that actually C has only 2 edges, so balance of each vertices are different. And you can actually take any much more, examples. So for example, this one is also the case of a graph with 2 vertices, and all the vertices of this one and this one are not the same, right? So here balance is 3, the balance is 1. Or if you want, then yeah. Oh, sorry. Then this one is also balance 3, 4, 2, 1. So this one is also different one. And so there are so many other kind of graphs. So there will be some problem about requiring you to draw the graph and scan it on, for your exam, right? So, okay. So I think that these are all the questions in the review. Okay. And if you have any other questions or any other problems I want to deal with, you want to deal with? All right, then, yeah, please, just since, okay, do you the thumb browser as an example for the exam? Yes, actually you don't need to use the lockdown browser because we will use the second device, proctoring. So in that case, you don't need to use the lockdown browser. Just use your Chrome, but set the camera so that I can see your laptop screen and your desk and yourself, right? So, but I will upload for set up lockdown browser for WebAssign as soon as possible. Great. So so this is the episode. So just ask anything if you want. So I will, I will definitely here right now from now to 4:30. So.
Will you do like an example of like the making fajita one with the listing process algorithm?
Making, sorry, what?
No, like doing like the listing process thing for like making fajitas.
Ah, okay, yes. Okay, so let's see this example right now. So making fighters. I think that here, yes. Can you see it? So yeah, so as I said, this onion and chicken is contained in the one process in this case. That's typo, so that's why I say that it is already 5 minutes. So here, first of all, we need to slice the onion and chicken into strips. And to cook chickens, we need to slice first. So that's why we have this edge from T1 to T2. And to now, and add onions with chicken. So it is called T3. So this part is T2 and this part is T3. And then add seasoning is T4. And also to add seasoning, you need to cook onion with the chicken. So these are the chain of the tasks. Then you can chop tomato without cooking chicken. So you definitely this next one T5 is independent of T1, T2, T3, T4. And you need to chop tomato to mix cilantro. So saying cilantro is T6, mixing with cilantro is T6, and it depends on T5. Then the last one is, next one is warm tortilla. Also, you can do warm tortilla without chopping tomatoes or cooking chickens. So this is another one. And to serve it, you need to put everything into one dishes. So that's why the last job, serving it, T8, requires all other jobs are done, right? So that's how I can make dependency of task or the requirement diagram. Okay, do you have any question on this part or? Okay, then let's deal with how to make Dijon Azure, processors. So since we did, if you have some priority list in here, in case of one processor, then all you need to do is using your priority list to adopt it. So for example, your priority list says that T6 to the first, but as I said earlier that in the time 0, all the ready task is T1, T5, T7, right? So you need to choose among T1, T5, T7 at the starting time using your priority list. And in here, you can see that actually T5 is the most prioritized one among T1, T5, T7. So you need to T5 first, then T5 was just, deleted. Then after 4 minutes, then now you are ready to T1, T7, T6, right? So here again, T6 is the most highly prioritized one. So you need to do T6 again and delete it. Then after 2 minutes, T6 was done. So after 6 minutes total, the only available process is T1 and T7. So using your priority list, T1 is the higher prioritized than T7. So you need to choose T1 and delete it. And T1 takes 5 minutes. So after 5 minutes, so it is total 11 minutes. The ready to job are T2 and T7, right? And again, T2 is the priority list, most higher prioritized than T7. So you need to choose T2 and delete. So, and T2 takes 10 minutes. So 11 plus 10 gives you 21 minutes. After 21 minutes total, then the ready to job is T3 and T7, right? And again, using your priority list, we need to do T3 first, right? So just take T3 and delete T3 in here. Then ready to job is T4. And after to complete T3, we need 5 minutes. So after 5 minutes, we are now 26 minutes are gone, right? So at this point, T4 has prioritized than T7. So we need to choose T4 again. And then T4 takes 1 minute. So after 1 minute, 27 minutes. Now you need to do T7 because this is already ready to job. And T7 takes 1 minute. And then you can do T8 to complete the job. And it also takes 1 minute. So that's why you can get 29 minutes per total. So in case of one processor case, just using your priority list, just figure out first what the ready to job is at given time. Then just using your priority list to choose the most prioritized job among the ready to task, not the whole task, right? So that's the case one processor. Do you have any question on one processor? Okay, then let's deal with two processor case. So in case of two processor case, we need this kind of table. Yeah, it makes us to deal with the scheduling much more easier. Oh, okay. So Dosun, was it by a mistake that in writing part of topic says that serving takes 5 minutes? Yes, it is typo. Sorry, this is typo. Thank you, Dosun. Yeah, this is typo. Yeah. Okay. No problem. Yeah. So, okay. So in case of dealing with two processors, then at the time 0, available processor is P1 and P2. And using the same priority list, T5 is the most prioritized one. So we need to put T5 into the processor 1. And next one is T1. So we need to put T1 into processor 2 to start. And T5 was done by 4 minutes and T1 was done by 5 minutes. So after 4 minutes, you can see that processor 1 is available. So, and now ready to job is T6 and T7. So at this point, you can do T6, right? Because T6 is the most prioritized one in the list, right? So, and T6 was done by only 2 minutes. So yeah, after 1 minute, and so at the time 5, you can see that processor 2 is available, and T6 now worked by processor 1. So all you can choose is T7 or T2, right? Okay, so here what we have right now is that T5 was done and T6 is now working on. So we cannot choose T6, and T1 was done by processor 1. So available job is T2 and T7. And from the prioritized list, T2 is prioritized than T7. So we can choose T2 for assigning job to processor 2. And T2 takes 10 minutes. And after 6 minutes, now processor 1 is just available. But you can see that the only ready job is T7 because now processor 1 just finished T6. So this T7 is, and T2 is worked by processor 1. So process 2, so processor 1 is, T7 is the only available jobs. So you can just assign T7 into the processor 1. Then after 1 minute, it's done. But at the time 7, still P1 is available, but there are no jobs we can assign for processor 1 because T2 is still worked by the processor 2, and all T3, all remaining jobs require the completion of T2, right? So in this case, you can set the processor idle. Yeah. So after T2 was done, so it's the time 15 minutes. Then there are two processors available, P1 and P2, but we have only single chain of line, right? So they are already ready. The task is T3, so you need to assign T3 first into processor 1, and also after doing T3, you need to assign T4 into processor 1, and also you need to assign T8 to processor 1 because there are no other jobs available for simultaneously. So using this, you can get 22 minutes from the processor. And actually, this is the optimal one because, yeah, in this diagram, the critical path is this line, right? So first line. So, and it takes 22 minutes to complete critical path. So, and it is actually agrees with what we have in the scheduling of two processors. So it gives us the optimal scheduling. Okay, do you have any question on this? Great, thank you, Dawson. Hello.